All right, so we are just about a full house here already. So we'll get started with the presentation. As you should be able to see on your screen, I should say a change of view using root imaging to expand your research by CID Bioscience. Online with me is actually our distribution manager, Susie Truitt. She'll be helping in the background, facilitating with the Q&A, as well as the overall structure architecture of this webinar. And as you're an attendee using the Zoom software, just want to give you a couple tidbits. If you go down, and it won't show up immediately, but when you scroll all the way down to the bottom of your screen, you'll see a bar pop up, and it should give you options like chat, questions and answer, as well as raise your hand if you'd like. So I'm going to give the entire presentation and a short video for this webinar, but at the end of it, we're going to leave plenty of time for questions and answers. Any questions, please put them in that Q&A box, and we'll be getting to them towards the end. Now, this webinar is being recorded, so if you have anything you'd like to see later on, if you want to come back to it, we'll be able to share this later, as well as if any of your colleagues need the information as well. So to get started, if I can, we'll be covering the CI 600 and CI 602. Now, the 600 has actually been around for about 10 years and is a in-situ root imager. And the 602 has just been developed as of last year using more recent technologies, being able to diminish the size of the root imager, but still keep it so that it can be applicable out in the field in already established tubes. So we shall. But first, let's cover why should we study the roots. One, it's a critical success for the whole plant. They are absolutely critical for understanding plant or crop yield, environmental effects, the additions of certain chemicals and elements, and greater emphasis has been placed on root study that no longer are instruments such as the minirhizotrons simply in the domain of scientists, but they're also being utilized by crop consultants, agricultural researchers, farmers, to understand the effectiveness of soil treatment, fertilizers, and other nutrient applications. They can be able to use for, say, measuring and planning for the impact of drought and temperature fluctuations, or monitoring for root pathogens and estimating crop yield. So root study is really, just an integral portion of the understanding of the plant's health and production as a whole. So getting back to kind of root study, a lot of studies are very much actually destructive of the roots, which really kind of has a hard effect to being able to visualize the roots in their natural biome, do a non-destructive assessment, and see how they grow, and being able to do a repeated over time assessment of both growth, application studies, and pathogens. So since their proposal by the J.H. Bates back in 1937, minirhizotrons have been constructed with a kind of a successive list of technologies, starting down with just mirrors, in order to visualize roots and provide means to non-destructively and repeatedly assess root conditions. So minirhizotrons have been utilized to study, again, plant response to drought conditions, compare treatments over time, my personal favorite, map phenotypes to genotypes, and overall find correlations between below ground characteristics and above ground function. However, minirhizotrons in the past have some major historical setbacks. In fact, even the rhizotrons that they came from, which were originally just very large boxes you would actually be able to walk into and have glass walls, have some issues you would have to deal with, including restricted accuracy, low image quality, limited size. I'd also like to put in here, very hard to replicate a very similar environment when you're allowing in other environmental factors like UV light. The great thing about modern systems, especially with the CI 600 and the CI 602, is that it's lightweight and portable. It's ideal for remote locations. You can use root tubes, glass to acrylic, and have variable DPI, so the dots per inch, and that's just the resolution levels which you're scanning, so that you can do very quick scans at low resolution, getting your information, or you can do more intensive scans at higher resolution, so you can see things all the way down to root hairs, mycorrhizae. So the CI 600 To answer a lot of the problems that minirhizotrons have had in the past, we've developed this over 10 years ago. It's portable, scanner-based. As you can see in the tube, the scanner is just attached to a sliding rod as well as a computer, which is off-screen. And the tablet computer, with that, you can just press go and you can scan 100, 300, or 600 DPI. And using both the cap and the sliding rods, you're able to measure as you go down the tube visibly so you know how many scans you're at. And the great thing with using technology like this is that you can do one scan at one level, slide it on down at a measured rate, do another scan at a different depth, and then later on in our Rootsnap software, you can actually take these scans, put them together to make an overall large picture of the root system that you're looking at in that location. We also actually provide, when we do give out the CI600, we actually provide 6 acrylic tubes, including with, as you can see here, actually clear. And we will be talking a little bit more on that later on. We actually provide them singularly as well. If you already have a CI600 or 602, we'd be able to get those for you. The 602 advancement is actually, it's it's 2 inches in diameter as opposed to the 2.5. Also watertight and insulated. The 2 inches actually fits into some existing installations for some older minirhizotron systems. It's a little bit higher speed, so we're actually able to get scans at 100, 300, 600, and 1200 DPI, which has been actually a really interesting effect on some of the research done on mycorrhizae and pathogens. Now I'm just going to go over a little bit of how the systems work basically. You have the tube in the ground, the imager, you just dig a hole in the ground, install the tubes, and you want to allow the roots to grow around them. Once that has happened, you can insert the imager into the tube, begin scanning, and then the imager will actually go around at 360 degrees to a full scan, and you can change the depths with it. Doing that, you're actually able to get a lot larger picture of the root system you're looking at. Now this is just going to keep replaying, so I'm going to go to the next. That kind of simple application allows a non-destructive testing for a lot of different applications, including root turnover, fine root growth, root hair formation, branching patterns and behavior, control versus treatment effects, root distribution, root interactions with like parasites and mycorrhizae and nematodes, and actually a whole lot more. So, we can do a lot of the application studies and tests here on our site, but a lot of this work has actually been done by researchers like you, and I'd like to kind of just show some of the examples. We do show some of these on our website. We try to get as many of them as possible, but so many are coming in where they're using especially the 600 since it's been around for 10 years now, and now the CI602, even though it's been around for only a year, there's already some requests coming in. But these applications are a wide variety. Here you can see they're across the globe from China to Spain to the United States. And they're interested in a whole host of different species and effects, including shrub species. You have a lot of grapes studies as well. Wetlands, this is able to be used in, and actually studies in permafrost and the tundra, which we'll see in a little bit. So being able just to use a fairly simple idea, being able to scan these roots, but at different depths and doing it a quicker, faster way and a better way of handling the data enables a lot more studies and a lot more work to be done in whatever field you're looking to do it in. Now I'm going to kind of cover the CI600, 602 installation and some of the ways of methods of putting it, these tubes in the ground. Mostly because that's most of the questions I end up getting right before going to Rootsnap. So with the CI600 and 602, we do suggest, if at all possible, you install root tubes during the previous season, just to mitigate as much of the detriment to the soil, the detriment to the roots that you're going to run to. Now, the plant by plant, it's actually going to be a bit different, of course, with your growing season. Some plants are very fast, rapid growing. Some plants just dealing with a poplar tree root issue. And those, for trees, are very rapid, but for most other plants, I wouldn't call that at all. But the more important thing is when you're installing these roots, that you just remember that you want to keep the environment as similar as possible in the soil around the tube. So that means not allowing UV light in, not allowing moisture in that is atypical to what you would typically find in that area of soil, as well as actually any other like temperature and environmental effects. So when we do sell these tubes individually, and when we give you the 6 ones with the instrument, we actually have installation caps and give a bit of ability to buy a gas-powered auger to install these. Now, the other things I would definitely mention off the bat, just having run into this experience myself, is you want to make sure that the soil is not completely compact around the tube. You actually want to keep it about the same density as you would typically find around that plant. That way the roots grow as they typically would, and not either bunch up because there's a lot of space and giving them a lot of space to grow, or completely avoid the tube because you've compacted the soil around and made it difficult for them to grow around the tube. And that being said, we have seen the 600s and 602s actually work in an entirely variety of different environments. This includes tundra, this includes wetlands, this includes very rocky soil, as well as very, very sandy or very clay-like soil as well. The setup can actually also be done to do repeated scans. Now, in this picture you see from the University of Copenhagen, you can tell that they're inserting the 600 into an already a tube that's been covered in, it looks like duct tape, just to make sure that UV light does not get in for their study. But what you can also do with that, if you wanted to do a singular location and just scan over a long amount of time, is you can actually just tell the software to do repeated scans, either 5 minutes, 15 minutes, up to actually 12 hours. So once you put that in, the actual scanner will just sit there, and every, say, 5 minutes, it would make a scan of the roots, and like again for 12 hours. And you can do this as long as it's plugged into a computer and computers has power. So there are many methods I also want to mention of installation. We do typically suggest using a 45, 60, or 60 degree angle. This is a little bit for historical reasons, as well as the does keep out, especially in environmental, helps keep out things like rain and other environmental factors. But this instrument actually works either vertically or horizontally as well. So you can actually, and I'll show you in a little bit later in the presentation, you can really install it in a lot of very ingenious different methods. So, and just to give a good example, here we see tubes in a horizontal method. They have actually installed them right throughout the bed of these different boxes. And this is able to, you can take the scanner out, place it in one tube, do your scans, pull it out, place the cap back in, and take the scanner out as well, and just keep doing that repeatedly, fairly rapidly. Being able to get a full record of, especially in that box, of all of these root systems for all the plants right there. In the right, just kind of showing some of its abilities to work pretty much regardless of the environment. You can see it there being worked at on the tundra. The 600 is doing scans there, and we found that it's actually the acrylic tubes have more problems with the cold than the instrument itself and using studies. And then just bringing it back to kind of a success of different studies between wetlands and very dry temperatures. We have Dr. Murthy and Dr. Srinivas at the Central Research Institute for Dryland Agriculture in India. Here they're just actually studying root growth and development of 2 maize cultivars under 2 moisture regimes. You're looking at actually one moisture regime right now, and as you can see, they're covering part of the acrylic pipe with PVC pipe, just so, especially in those small biomes, you're not allowing the UV light in to keep the roots from growing around the tube. And here we see more of like an orchard application where we do have the 45 to 60 degree angles of tubes. But again, this is actually right around different pumps, right around in very moist, sometimes very dry environments from Demanio Zanatelli of the Free University of Bolzano, Italy. And it's just to kind of give some of the breadth of the applications. You can see that here he's studying this roots dormant during winter months, as you can see highlighted using the Rootsnap software. And then activity and growth in the spring and summer. And being able to do that is just because you're able to take this instrument and scan in the same location repeatedly. And I'll show a couple of techniques a little bit later on how to scan the same spots. But a lot of the work, so the scanner itself is really just for scanning and making sure you can do it out in the field. It is connected to a tablet that we do provide, and we'll show in a little bit. And the tablet actually will be coming with the software for both scanning, calibrations, as well as our Rootsnap and image analysis software. This isn't to say that only the tablet can run it, it's just what we have found to be the handiest when you're out in the field. The image analysis software can actually put on pretty much any computer, as well as the scanning software. Now, the great thing with this is actually you can start playing with it today if you would like. We do provide it for free on our website, and we also include it with each one of the 600s and 602s. And we're constantly updating it. There's actually being some updates being pushed fairly soon, within the next month by our software engineers. But it is a very easy and fast tool for analysis. Prevents backlogs of root images by being a lot quicker way than more traditional means. And it has a few features that I actually really enjoy. I think make root analysis a bit easier than I've been typically accustomed to. But then using the roots where you're mapping it out, it actually does a lot of automatic calculations. So you can get things like root count, total root length, total root volume, total root area, diameter, length, area, volume, and the average, window depth. And you also get the date and time of the images, so you can actually do a very quick study on what times, what variables that you might be running into. You do get actually a physical size of the image. I'm going to show you in a little bit, as well as being able to do scans and, as I said before, interlace them together to make a far larger picture. And then from that, you can actually get things like not just the individual roots, but overall systemic architecture for like branching angles, branch counts, and diameters of each one of the individuals. So let's take a look at what that looks like. Again, let's use Dr. Murthy's scan because I really like the coloring. And here you can see on the, put over here. On the left, these are actually multiple scans put together and stitched together using Rootsnap. And so we will blow up one of these little sections just to show what they've done previously with their root scanning software and how it can look when you have mapped it entirely out. Now, as you can see, many individual roots are present in a single image. So for each root colored and mapped, the data that we've discussed in the previous slide has been recorded automatically in the software. And you can actually open that up and view it at your leisure. It does open up in like kind of a panel side. So you can actually just watch it change as you're doing your adjustments to your roots. So that is the bulk of what I was going to discuss with the CI600, CI602. We do have a whole range at CID Bioscience of different instruments to work with, so including the CI110, which is a plant canopy imager, which we actually just gave a webinar about a month ago on, and the 202, the 203, both leaf area meters, the 340, a handheld photosynthesis system, as well as the assorted softwares actually for each one of the devices, and a CI710, which is just a miniature handheld leaf spectrometer. So all of these are also available. I'm sure at the end of this presentation, we're actually going to be putting out a poll to see which one you would like another webinar on, and we'd be happy to have you vote on it. Now our Susie will be sharing a presentation on the video, just giving a kind of in-field representation of what it looks like if you're running this. And I'm going to give a little bit of a discussion and kind of explain what's going on. So again, we are seeing images of the CI600. There you have to see like the locking nut to keep the serial port in place. Now, really being able to do non-destruction imaging in the field. Here, we're going to show you just all the pieces that come with the instrument, including the calibration tube. You have the scanner itself, as well as a slider rod. Actually, there's like a dozen names for this thing, but what it does is you can just attach it in to the scanner, like so. Slide it in, slide it out, using the wheels attached to the scanner. And those rods actually have different links. So you can use these links with the cap that we also provide to kind of measure out as you're placing the scanner into the tube and then using it at different depths. And then it's pretty simple. This is actually the laptop right now that we are providing with the CI600. And it's fairly plug and play. Once you do a calibration, this is the home position. You stick it into the calibration tube. And we do suggest that when you're doing your individual tubes, you actually utilize those two dots as well, kind of marking it at each one of the tubes. That way, when you're doing your scans and you're placing it in, you're just getting the exact same scan location every single time. It's not we find it just makes research and data a lot easier. It's not a complete detriment if you don't, because it is a 360-degree scan. These are some tubes we have actually installed in our own area. We do put kind of a foam core in to keep the UV light, but as you've seen, duct tape, PVC pipe, there's a lot of different methods to make sure that roots are growing in that area. And here, we're actually putting the locking cap on. This locking cap you use to both make sure that different environmental effects, UV, moisture, aren't getting down into there and changing the environment, as well as you can actually lock it in place with the slider rod and just change the depths that you're using it at. And to scan, it's pretty quick. So here we have the Rootsnap software in use. As you can see on the left, I have a certain set of image statistics set up, but you can use it just on your computer very easily using mouse. You can actually change the diameters just using the scroller if you'd like. The image as well, just so you can visualize better which the roots. I prefer actually using the touchscreen very well because it's, especially when you're doing a lot of roots really fast, it is a lot faster method. It does do some thresholding, so you can kind of get an idea of how much roots are in the bulk of it. But also, as you're mapping it out, it is doing the selected points and taking all that data with it.